Now I've got to talk like a robot. No, I'm playing. That's totally joking. So, what we're going to do is first off, I want to go through Blackboard. I want to show you around here a little bit. Man, I got such a tiny little tether here. So I'm going to just use the mouse and hey, look at that. So I'm assuming that you can get into Blackboard. If you can't at this point, then we need to start talking, okay? If your name is not on the roll sheet, then just still sign your name. It might be just a little technical issue. But I need you to get into Blackboard, and if you're not, then tell me, okay? Once you're in, then here we go. It says start here, so I'm going to start here. And we've got the syllabus. This sounds so fun. Let's plus sign a couple times. Blah 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 blah. Due dates. Awesome. So again, I want to like run over there right now, but I can't, so it's okay. We have due dates. The first due date is on the 2nd of September, and if you go to the calendar and wait for it, that's going to be in 2 weeks essentially. Okay. So 2 weeks until the first due date, and I think there's like 3 homework assignments and a tiny little quiz for it. Again, all definitions, all words, no math yet, and that's okay. After that, I think the due dates are about every 2 weeks or so going forward. And well, there you go. The biggest stuff, man. You know what? I'm gonna go run and grab my little cable. Okay, I will here in just a second. But the longest chapter is actually going to be chapter 9, and so I'm going to warn you ahead of time right now that these due dates around this time, they're going to seem like way too late. We're going to be ahead of schedule. After exam 1, we'll be ahead of schedule pretty quick, like, okay, because these are kind of short. But I need to be ahead of schedule so that we can get to chapter 9 where it takes a lot longer. Okay, so that's one of those kind of trade-offs. Sound good? Okay, so I'm just keeping you warned, and I'll warn you again many times as we keep going. Um, so after that, they have the exams. You can see that there's a 3x5 note card that you can have. For us, I would think it would be more important for definitions because there's a lot of words, and if you can write down a couple definitions that help us remember, because I'm not good at memorizing. Are y'all good at memorizing? Oh, good. I'm not either. So, anyways, that's what it's useful for. Everything else is pretty much just GeoGebra. Very rarely would we have a formula at all, because everything's done on the computer. Points distribution. You can see that homework is and quizzes are weighted pretty heavily. So the only things that you have to take here proctored are the 3 exams. So exam 1, exam 2, and final. Those are the only ones. Everything else is done at the house, and that's fine. Lots of points to be done just at the house. Okay, cool. Or you can even do it in class if you want to. Other than that, I think it's just a lot more blah blah. Thank you. So any questions in particular about, I don't know, due dates, things like that? Y'all okay so far? This is the basic stuff, right? I told you you're going to be bored, right? Man, I can't believe it's going to be so boring. I'm just playing with you. So, okay. Course contract, you don't have to sign it. If you signed in right there, you're good. So I had somebody ask me about that earlier. I was like, it's only for online folks. I don't think the lessons are going to be important, but this Newton Alta is going to be very important to us. Okay, it says somewhere. I thought it said somewhere that we like most of your work is right here. 95% of your work is through this program called Newton Alta. And if you ever had like my math lab before and maybe another algebra class or something, it's not like that at all. So it's actually a little different style, but for the better, especially for this kind of course. I want to show you around there as well, though. So Newton Alta coursework is where we're going to go, and then they have like every single homework and quiz assignment all right here. And if you want to practice, there's this test review center, which I'm going to be using especially when we're getting ready for exams. Okay, so all your assignments are right here. You're like looking at them right here. This is it. When you start to click on one, it'll have you register. I think you get like 2 weeks temporary access. Eventually, you have to pay for it. I think it's like 40, no more than $50. Okay, but you can buy that at the CTC bookstore or directly online. Cool. Okay, awesome. So, can I show you this? Can I jump into a homework? Let's just see what it looks like, right? So, homework 1-1. Let's do it. And launching a new tab. That's fine. Cool. No. I want to view. Preview as a student. That's what I needed. Don't look at all these settings. No. Cancel. Preview as a student. There we go. We're figuring it out. Ah, there we go. Yes. So this is just a basic view of what your homework would be. And in fact, in chapter 1, multiple choice. Almost always. Are you already bored? I know. It's going to be just 2 days of this. I know. But true or false? Blah 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 blah. True. And dang. And it says all the stuff, and really here in chapter 1 in particular, all this is really helpful. It tells you why you got it wrong in words, because it's a lot of words for right now. Continue. So it asks basically another question. False this time. I didn't click it though. Oh, man. One day I'm going to get this, okay? Hold on. Just click the top one every time. We got it. We got it. Okay, cool. Now, as I continue, look up here at this little thing. You see it says 7% right there. I think it's either, okay, it changed to 7% because I got one right. Okay, so let me try to get this one right, and I'll see it go up. Okay, so give me a second here. Donald's studying, he samples, dividing them into equal groups of this and that. Oh man, I don't even know. I have to go back and look at these things too myself. Proportionate number of this. We're gonna do stratified. Here we go. And yes, I'll teach you all about this here in a second, but I just wanted to show that the percentage went up. And that's how, thank you. And that's how it goes. So you keep on doing this until you get like a 100 essentially. And that's, they're going to keep popping new questions at you and stuff like that. Does this look like My Math Lab to you at all? For those of y'all who use My Math Lab? No way. It's completely different. So in a fun way though, in a good way. Okay, cool. So any questions on like how this works? Is that okay? Access code, well, temporary access right now, they'll offer it to you free. No, so you're already signed up. As soon as you click, I'm gonna get back to it. As soon as you click like one of the homework assignments, it automatically registers you. Yes, and so it's all through Blackboard. Very good question. Thank you. Cool. Any other kind of particular questions? Yes. Or pay directly online, debit, credit card, that kind of thing. A few different options. Perfect. Yeah. Yes, it is. Yep. They have the access codes there. Just tell them what class you're in, and then they would have the options. You do not need a textbook. You do not need a calculator. You could have the workbook if you want, but definitely access code for sure. Very good. So like if they offer you a textbook, you could just say no. If you want to, okay? I think that there is an online textbook for this somewhere, and I would have to. Oh, you know what? It is. It's the OpenStax version. Here, hold on. Let me just go to it right quick. I don't know if y'all are like actually textbook people. I haven't used a textbook in I don't know how long, but OpenStax is kind of like free textbooks, and that's what we linked ours to. And so, do they have statistics up here? They have math. Let's start with that. I'm pretty sure they have us. There we go. Now, it's not the business one. I think it's either one of these. I think it's this one because that's the high school version. So it's probably this book here, and you can just download it directly, kind of stuff. It's all pretty seamless. But again, I haven't ever used it in years. So cool. Just an option. Don't buy a textbook unless you really like to fall asleep at night reading. Okay, because that's the only reason there. What I do recommend, though not required, is to get this workbook. And sorry that she's circled now. But anyways, that workbook is what I'm going to do on a day-to-day basis. It has all the definitions. It has everything you ever needed. You can use it on your homework, and it can help you like get to what you need. For an example, we were talking about that stratified thing I just clicked on just a few seconds ago. Well, if you scroll down enough, eventually, like this is all today and tomorrow, that kind of thing. Here we go. Stratified right there. So, well, I crossed through some of the definition, but the idea is that we have this, we can go and look it up and say, that's what they're talking about. We can reference it. Good question. Let's go to that. So, I have it for free here under student resources. So right here is the workbook for free, and that's digital. If you want a physical copy, you have to go buy it, or print. Your call. So yeah, that's what I recommend. Thank you for that. I forgot about the digital version. Cool. Good? Yeah. I would not purchase anything until you know for sure. Yeah, like use the 2-week temporary access for now. Bug people, ask them to do it for you. Very good. Good question. Yes, very good. Cool. I'm going to show you one more thing. So I'm like recording right now, right? But we have these pre-recorded lectures, not by me, but by one of the other professors. Her name is Ellen Falkenstein, and she's been doing this for probably longer than me. But I just clicked on it, by the way. There's this co-rec lecture video things, and there's all these different links here. And I mean, they're spot on, you know. And I think if they don't go through this workbook, they would go through something similar, very organized. So in case you don't show up to class, you have my videos I'm doing right here in class, and you have hers as just like a second reference. Okay, awesome. All right, cool. Thank you, guys. Okay, so are we going to get started on math now? Or not really math. Again, I told you it's not math, right? It's going to be words. But I do want to get to doing it, and I need a longer cable. So I'm going to run upstairs real quick while it's recording. So you got to be quiet. I'm just joking. It can't hear you much. I'm going to start here at the top, and in the meantime, read. Okay, I made it. Thank you. Yeah, I ran all the way. It's okay. Someone's got to, right? This is gonna cut out for a second. You still hear me? Hello. Hello. I think so. All right, we're good. And now, look at this, guys. Watch this. Yeah, I know it's super cool. Anyways, so let's get working on the workbook, and we'll just do as much as we can here towards the end of the class. We're actually going to go to the advanced math lab and to go see where we're going to take our exams and where you can go get tutoring help. Okay, cool. So here we go. And I know, like, we're starting day one and we're already doing some stuff here. So starting with sampling and parameters, statistics and population. I'm going to plus sign a little bit so we can get a little bit more personal here. Statistics versus the population, that's the really big stuff here, okay? So, or, yeah. No, hold on. Yeah, all of them are there. I want to erase. Hold on, erase. Okay, sorry. Population sample, there we go. We'll talk about statistics in a second. The reason why I was confused is because we got P's and S's. The P's are always together and the S's are always together, okay? So if they ever say the word sample, you're going to link it in your brain to the word statistics. See how they both start with an S? Okay, cool. Erase, because I didn't want to do that. And if you ever see the word population, we're going to link it to the word parameter. And do we have that word up here? Right there. There it is, parameter. So population, parameter, parameter. You caught me on an off day, guys, where I was just running, and now I'm all like exhausted and stuff. Sample statistic. So let's talk about the class that we're actually in here. We're in statistics, right? What does that mean? It means math, right? We're doing math, but we're doing math with who? Sample. Statistics, samples. They're linked together. So what is a sample versus a population, right? Right here, this class. We're a sample because we have a group here out of CTC students, right? And so we would be a sample when you're looking at the entire campus. Does it make sense? But at the same time, an interesting thing, we also are a population because we are an entity unto ourselves. And so you could say then a sample from us would be just the guys or just the girls or something like that. So what we're doing is we're looking at it relativistically. We can even say like all the folks here in Killeen would be a sample as long as we're talking about Texas, or maybe all the folks in Texas would be a sample if you're talking about United States. Does it make sense? So wherever you are on the tree, I guess, you can consider yourself one or the other. Say that again, I'm sorry. It would be the math that we would get from a sample. Yes, percentages, averages, all that. That is the math side, and that would be, I guess, what you would call statistics, literally. So yeah, because it's the math behind it. Okay, very good. Good question. Okay, so their definition is population is all, and so that'd be all Americans, all CTC students, right? All the people in this class. Does that make sense? There's other key words they're going to use, not just all, but each and every. So if you ever see the word like each student in the class, every person in America, they're talking about population. Okay. If you don't see that and you see the word subset, then they're talking about a sample. Okay. And again, they relate back to statistic or parameter that way. All right, so it says determine whether the data is a population or a sample. Okay, so we're just doing what we were just talking about. So the salary of every teacher in the school. So are we talking sample or are we talking population? Population, because what word? Every, right there. Every, exactly. So it's a population. It's going to be this guy or this guy, one of those. I don't know which one yet. So let me read now which one makes the most sense. Because it is a collection of salaries for all teachers. That sounds pretty good. Okay, let me do the other one. Because it's a subset of all. Do you see that word subset? That's not with population, is it? They're trying to confuse us. So yeah, it would be A in this particular case, okay? And so you can see how we're like doing deductive reasoning here, I guess you can say. Is that cool? Okay, good. All right. Grades of 5 students in a classroom of 5. Are we looking at a sample or a population? A sample, because it's a smaller group of the whole, right? 30 people, we're going to take 5 and see what they do. That's a sample from. So definitely it's going to be A or C. So here we go. Because it's a collection of all students? No. Because of the collection of 5 students is a subset. Aha. Keywords. Is that making sense? Cool. Okay, good. Awesome. If you all have questions, you let me know. Okay. There's a lot of blah blah going on here, but I guess we can kind of get down to some of this stuff. So data, we're going to have charts, and we're going to have tables and statistics like percentages, all these things. I guess they all come from data. I mean, I guess you could read it if you want to. I think we all kind of know that stuff there. Remember that parameter and statistic are related directly to, again, population or sample. And so how do you know if something was a statistic or a parameter? Is because you know it's a population or a sample. It's what we just did, right? So we're going to start with that first. But notice that it says like the number. Oh, there it is. Look, P and S. Oh, I knew it was somewhere in here. I know, it's going to be 2 days of boring. I know. We're going to get through this. So, but these right here are more of the math side of things. And so that's where your percentages and averages and stuff like that. So a statistic would be math from a sample. Okay. So you're interested in how adults in a country feel about legalization. A poll of this many adults in the country were asked if they're in favor, and they had 48% say they're in favor. Describe what's going on. Okay, so I want to first off understand, like, I guess, population sample, that kind of stuff. We got 1,001 adults in a country. So what are we talking about? A population or a sample? The 1,001's a sample, and the country would be the population, right? So if we're talking like right here, like USA, right? There's no way there's only 1,000 people in the United States, right? So that would be a sample from a population. So these guys right here, I'm going to say, are definitely a sample. Sample. Okay. So from those respondents, right, from those people, we found right here this number. And so I'm going to ask, because it came from a sample, do I have a parameter or do I have a parameter or do I have a statistic? A statistic, because again, it came from the sample, S with S, P with P, right? So we know ahead of time it's a sample. Now I know therefore immediately that it's a statistic. That's how it works, okay? So what is the population in this sample? So what's the population A, B, C, D? D, all, there's another keyword right there, all, each, every, right? In the country, yeah, so United States, that would be my population. So therefore the sample would then be A, the 1,001 selected. The subset, here, I'm gonna write subset from there, subset, awesome. Cool. All right, and so I don't know about the variable of interest and the data collected. I don't ever remember seeing that on the homework, but maybe things have changed. So I can go back up here and look. It says right here, the variable, either X or Y, is a characteristic of the interest of this and that, numeric and all that stuff. The data collected. So looking around, how would you reply to some of these things? What about the data collected? I think that's an easier one. Yes, we got the respondents' results, say if they were in favor or not, and we had 48% of those there. So, like, what do you put down here? You know, that's up to you. I don't have a good definition, honestly. And that's part of my fault of just being more mathy, honestly. We're going to have some of these kind of questions, but we're going to also kind of move through them as we see them. Okay, so variable interest, I'm going to say legalization, question mark, right? Because that's what we're asking. And then the data collected would be their responses from the sample, and which led to me finding that it was 48%. Now, see, 48% in favor, what does that mean of people not in favor? Wouldn't it be like 52%? But that's still data, isn't it? And so, in a way, I can't disclude them. 48, yes, but 52, no. Both of them are important. Just how you kind of see it. So 48% is a blank because it's a value that describes the blank. I think they're talking about statistic parameter kind of thing. So I'm going to write these up again. So statistic or a parameter, because it's talking about the sample or the population. Okay, so 48% came from which one? What do we use here? Sample or population? Sample. Because it's sample, we use which one? Exactly. So we're going this way with it, right? Logically. Good? Now here's a question for you. Why do we even have samples, right? Why do we even have 1,000 people we're asking? Why can't we just ask everyone in America and just be done with it, right? Exactly. Right. You know how we have the census every 10 years? So try to put something like this on the census. I mean, that's actually more of like a normal thing nowadays. It's one of those more common questions that they would start asking folks. But like, what if I wanted to know something else? What if I wanted to know your favorite food? Yeah, I'm gonna say, hey, can we put it on the census this time around? Oh, like, yeah, let's hear it. Do you like hamburgers? Would that go on the census? Probably not. They're not going to let me put that on there this time. And so we need to then take a sample and ask people, do you like hamburgers? Do you like hamburgers? Do you like hamburgers? And we can go down the line and find those numbers that way. It's just easier this way. Not always the best, but definitely easier. And it gives you a nice estimate of what everyone's thinking. Now, 1,000 people, is that a lot of people? In my opinion, yeah. When we keep going, you'll see the magic number is actually 30. Once you hit 30 and more, you're like, that's a good sample, practically. Moving on. So Timothy wants to estimate the percentage of homeowners that own at least one dog. He surveys 100 people to determine if they own dogs. What's the parameter? Now be careful. He's surveying 100 people, and they're saying he wants to know homeowners, and so he selected 100 homeowners. Is that a sample, or is that a population? Okay, he surveys 100 selected homeowners. Mm-hmm. Like I'm looking for the word each, every, all, right? He went to all 100 selected homeowners population, but he's just saying 100. What? How many homeowners could there be? Like in Killeen, let's say. That's a lot, right? So in a way, I'm thinking that this is a sample, and yet they're asking about the population here, right? See how they're kind of twisting it on us a little bit. Okay, so what's the parameter? Now, again, it's not the population we're looking for. Again, all homeowners make sense, but again, we're looking for parameters, the math side of things. If you go back up, like why do we use different words? It's because these are math. It's the numbers, it's the data, it's the percentages, the averages, okay? So I wouldn't say this one just because it doesn't have math in there. Specific responses of the survey. Percentage of all homeowners that own at least one dog. You see that keyword all? And it's right here. What does this mean right here? Math, right? So right now, that's my favorite. 100 homeowners surveyed. What is that? What would you call that right here? The sample. And then it says the percentage of surveyed homeowners. That's the sample, by the way, right? So they're saying the percentage of the sample, but that's not what we're looking at here. They want the population, right? So this is my favorite. Again, sometimes it comes down to like, I think that this one's the best. Does it make sense? Okay, it's not a perfect science here. It's math. Anna wants to estimate the mean number of siblings for each student in her school. See, I'm looking for these keywords. She records the number of siblings for each of the 75 randomly selected students in the school. What is the statistic? So now they're talking about sample stuff, aren't they? And so it's kind of interesting here. What is the 75 selected students? Because it seems like each of the 75 students, it sounds like that's a population, but it doesn't make sense. A school to only have 75. I guess it's maybe like a small one, maybe. I don't know though. So they're looking for the math for the sample, and the only thing that I can think of sample would have to be that 75. They don't give us any other clue. Does that make sense? Okay, so then the population would be what? The school, the whole school, whatever the school is, and then we're going to sample 75. So specific number of siblings for each of the randomly selected whatevers. All of the students in the school, that's just the population. The mean number, whoa, mean. Do you know what that means? Average, exactly. It means math. It means average, by the way, if you want to really know. But it means math. And so we got the math. That's already a good thing right now. For all of the students. Whoa. That put a downer on it. Okay, hold on. The mean, we got math again. That's what we're looking for of the selected students. What do you think? That's my favorite so far. And then they're saying, hey, 75 selected students. That's just the sample, isn't it? It's not the actual math for the sample. Is this okay? Okay, keywords, right? Okay, good. Are you bored yet? I told you you'd be bored. Only for 2 days. It's okay. Then we're going to really get math, and it'll be fun. So descriptive statistics, inferential statistics. So involves organizing, summarizing, displaying data, just like I was saying, the charts, whatever, and then sample data to draw conclusions. This is one of those where I always get confused about which one. There's too many definitions, and I need a note card. And that's why I have one for the exams, right? So I would be putting this on there because I can't ever remember. They're going to ask, hey, what's the inferential statistics of blah, blah, blah. I'm like, what? Because I've been using like all this math for so long, I just forgot about the words. So here we go. Let's use those here. Suppose we have a survey of 525 women in the United States, found that 68% are primary investor of the household. Which part of the survey responds to the descriptive branch of statistics? That's talking about this guy, okay? And make an inference based on this. And so first off, before we go any further, they're wanting to know what's this descriptive statistics? What's the tables, charts, averages, percentages, the results of this? A, B, C, or D? Which one sounds the best for you? I can wait. I know, you're like, okay, Chad, you got to tell me. I don't know. Okay, so here. Let's go down it. So I got 525 women surveyed in the United States. What is that? That's a sample. Is that descriptive statistics? No. Okay, so let's move on. So then, is there's an association between U.S. women and primary household? Blah 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 blah. You know what? To me, that sounds more like they're drawing conclusions. Does that make sense? It's not the actual thing that we found. It's just that now that I've seen this, this is what I'm thinking. Thesis statement. But that's not what we're asking for here. We're looking for descriptive statistics. 68% of blah, blah, blah. Right now, that right there, that's summarizing something. That's kind of like an average in a way, isn't it? You see how that is the math. That's what we're needing here. And then there's an association between this and that. I think that this is going to be my winner for that one. They're just wanting what was the numbers. Okay, your homework will be like this. They're going to ask a really weird question like this, and you're going to have to go back to this workbook to see what are they trying to say. Okay, so choose the best inference for this. So we're trying to infer something about it. We've got 68%. That's pretty significant in my opinion. And so what can we say? That there's 525 women surveyed? True statement. Didn't really tell me anything though, right? Okay. There's an association between U.S. women being primary household and being the primary household. That's pretty nice. Isn't that kind of like a nice statement there? It sounds pretty good. 68% of women. Well, we already said that was our descriptive statistic, so I'm gonna knock that one out. And then there's an association between the 525 women being the primary investor or whatever. So hold on a second here. Go back up to the top. It says we're using the sample to draw conclusions about the population, right? So I'm going to ask y'all right here, right now. Here's a little survey. You ready? Who in here likes pizza? Come on, who in here likes pizza? Okay, 1, 2, 3, 4, 5, 6, 7. I'm going to go 70%. 70% of all of Americans like pizza. We're done. Y'all are Americans, right? Come on. And so the point is that, I'm drawing a conclusion from it, right or wrong, from us about America. Does it make sense? So what we're needing here is there an association between U.S. women from the 525? Does that make sense? No? Okay, that's my favorite right there. We're going from 525, and we're going out to how many women are in the United States? I don't know. What, like probably 180 million, something like that? Somewhere around there. A lot, yeah. A lot more than 525. So, again, we're saying whole United States is going to go this way. Any questions? It's math. There, I'll just summarize it for you. It's math. Yes. Yeah, it's just part of it that we're doing the math thing. And then this one is to draw conclusions and make it sound good. And you must be bored, I know. It's just 2 days. It's okay. We're going to get through this. I'm just picking on you. It's okay. We're good. I mean, it's just classic for this class to be boring at first, but we will definitely be moving on soon. Census versus sampling versus all this stuff. So sampling is literally from a sample. Yeah, that makes sense. So census, we talked about this earlier. What's a census mean? Don't look up here. It's the entire population. I'm saying all of America, right? I'm saying all of America is going to get this survey. We're going to see what happens. So I'm just going to say all of the United States or all of the population. A sample is literally just a part of it. And so that could be, for us, it could be Texas. It could be Killeen. It could be CTC. Okay, so there's like a lot of different portions. It could be this class. Okay, and random sample, this is just the thing right there, the keyword's random. It's random to do it. There's different ways to find random stuff, but we're going to get to that as we go. Cool? Moving on. Simple random sample is simply random. There you go. Simply random. And I mean, however you want to go about it, it is what it is. Sometimes they want to use these kind of tables. I have never seen this on the homework, and I honestly don't want to use it here. But how would you find random numbers, let's just say? What would you do? Come on, humans. Tell me what you would do. There you go. Look it up on the internet, right? Roll a dice, maybe, right? That's another one. You could pick a number from a hat. So there's a lot of different ways. What they're trying to do here is they have a whole lot of random numbers, and then they pick like 3 of them in a row, and 843. And yeah, we're not going to do that, okay? I'm going to keep moving. If it's on your homework, we're going to see it ourselves because I'm going to pull it up here later. I'm sorry I got through. I crossed through that. It's still important. Okay. If you're going to have anything in the brain that's important, so far I'm going to tell you sample population, and that's related to the statistic proportion or parameter, sorry, and then these guys. So we have stratified, cluster, systematic, convenience, and technically the one above it still was the census. That one's still actually part of it, okay? And so these 4 or 5 different ways of sampling are very important. There's going to be a whole bunch of questions about it on the homework, and you already saw one of them, did you? So let's go through it. What do they mean? So stratified, divide each population into groups and select a proportion of that group there. And so I'm okay. Sometimes I kind of get confused with all the different back and forths, and I know I'm your teacher and I don't know. But this is good for chapter 1, and you'll never see it again. I think that it's going to be a little bit of everybody. That's kind of what I would say in the English version of it. A little bit of everybody. Here, I'm going to write that down. I want to do an eraser now. Hold on. A little bit of everyone. I think the picture is a little bit the picture's okay. So here's an example. If I wanted to take a sample from this room about who likes pizza or not, would I only ask the women, or should I probably include a few guys in there too, right? So a little bit of everybody. I want to make sure that I ask like some of the math people, some of the English people, some of the history people, some of the science people. I want to kind of include a little bit of everybody. So like you can see here, from low income, I'm going to pick a couple of the lows, a couple of the middles, and a couple of the highs. You don't want to exclude anyone. Does that make sense? Sounds good. So that's a good way to get a sample. You can't get everybody, but at least you can get a little bit of everybody. Cluster. So this one's more of a physical thing. And so you're subdividing them for a physical thing. They say, I think this is zip code, but you can also do area codes. You can even do the first initial of your last name. And so in the phone book, you would have all the A's. In the phone book, you have all the B's. In the phone book, you have all the C's. So you're like, I'm just going to take all the B's and go sample them. So you're going to get all kind of different people, right? It doesn't really matter whose name starts with a B. You're just going to get a whole lot of people. They're physically connected, and it's disconnected from the question you're asking about, okay? So I don't know, how would I say that? Physically connected? Physically connected. But it's also not important as per like the question you're asking. Like if you get all the B's and you're like, hey, how does it feel to be a bee? And you're like, you're asking the wrong crowd. You should probably ask a different question or get a different sample kind of thing. Does that make sense? One of the good examples is that they had this area code, zip code stuff. And there was like a hurricane that came through and it like wiped out zone 1, but everyone else was okay. And then they go to zone 1 and only ask zone 1 and they say, gosh, how bad was that hurricane? And everyone's like, gosh, it was the worst hurricane ever. And like everyone else was like, okay. But at the same time, couldn't it be interesting if they picked zone 3 and everyone was okay? How was that hurricane? No, it's fine. It's just a little bit of breeze. But everyone's hurting in zone 1 and you never asked them. Kind of makes sense what I'm saying? So you would have to be appropriate for it. You don't ask about hurricanes and try to zone them off. You would do different things for that. Systematic. The way I do this one is every Kth person And I'm trying to emphasize the fact that it's not every 100th necessarily, but it could be every 100 people, every 1,000 people, every millionth. So you're going through the store and like, oh, you're the 100th person to walk through the store. Congratulations! You get to take a survey, right? And it could have been anybody. Who was the 100th person? Second 100th, whatever. You can go through the phone book. I know there's a thing called the phone book, isn't there? And you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Call that person. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Call that person. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Call that person. Right? And eventually you would have a nice big sample. And who the heck knows who you're calling, right? And they're not going to like you. Just calling people. Is that making sense though? Yes, it just depends. So I get the Killeen phone book, and so that's the population, and then I'm going to just go through all the people in Killeen. Yep. So it just depends. Or CTC, I can just go down the CTC ID numbers every 10th or whatever. Yep. Very good. Good question. And finally, convenience. And so convenience is just, it's easy picks. It's easy picking. And because we live here around Killeen, Cove, whatever you want to call it around here, something that would be convenient would be holding out a sample, a survey in front of Walmart, right? So like we all go to Walmart. I don't know if maybe you go to HEB, that's fine. So you go to Walmart, and you're standing outside Walmart, and you're doing a survey, right? Well, that's like, it's easy for you, but now you're only getting people who go to Walmart and not HEB, perhaps. I don't know. It's just we would normally say the street corner. You're on the street corner, asking folks to take a survey, but here in Killeen, that's not really the same thing here, right? You say Walmart. Is that okay? Good. Okay, so that's just easy. Is that always the best? No, but it is convenient. It's easy, and sometimes it could be bias. There's the word bias right there. Okay, so those are all very important. I want to do a lot of questions about those, okay? Because that's what your homework is going to be. And this is exactly what we were talking about earlier on the homework. It looks just like this. You pick which one. Here we go. You're going to help me now, right? So to determine body temperature, she divides up her day into 3 parts. We got morning, afternoon, and evening. Then she measures her body temperature during the day. So which one of these would make sense for that? Which one? What do you think? Systematic. So every 10th time she remembers, she's going to take it. Stratified, a little bit of everything, right? A little bit in the morning, a little bit in the afternoon, a little bit in the evening. That sounds pretty good. Anybody else say anything else? I would say the stratified. Again, we're trying to do the best, and I'd say stratified. We're doing a little bit of everything, right? Not just in the morning, also in the afternoon and evening. Okay, so that's good. Yes. Questioning college students as they leave a fraternity, and they're asking about their drinking water habits. that was. I'm just joking. You get the point. Which one would make sense for this one? Convenience. It's really easy to be standing outside there saying, "Hey, how much water did you drink last night?" Okay. So you're doing a small study to determine the opinion of students at your school regarding stem cell research. You select a class at random and question each student in the class. And I want to kind of emphasize this part too. Okay, so each student in the class. Cluster. They're all connected with physical beings. We're all physically in the same room, right? And it has really nothing to do with stem cell. So you might think stem cell, you might think no stem cell. I don't even know what stem cell is. I don't really care. But the bigger point here is that we're all connected together, cluster, okay? And it doesn't have anything to do with the question itself. Like maybe, and this is just me, what if they went to a biology class and asked about that? That might be different. Does that make sense? I don't even know what they're asking about, but the point is they might know, and maybe they'll have a different opinion than a general other classroom. Cool? Okay. So you are conducting a study of health of every lung transplant patient from a hospital. You collect records from all lung transplant people in the hospital. What do we do? Notice there's a different option this time. You see it? Census. Yep. And they emphasize it twice. It said each, every, all. Population. Now, I know that it's not the census of the United States, but it would be for the hospital. Every patient. Okay, cool? Okay, cool. Any questions on this? There's only like the 3 or 4 questions, but like there's a lot of homework about it, okay? And it really is an important topic we carry through. We don't use it every day in this class, but it will be on the final exam. There you go. So I can tell you that much at least. So guidelines to designing statistical study, there's a whole bunch here. And what Newton is going to want for like its homework, it's going to go through a question and you're going to try to find where it is and you're going to like tell it the next step kind of thing. To me, it's actually a little confusing, but we'll try to get through it together. So a consumer research company is interested in determining if a certain company's new refrigerator model is more efficient than the older one, which might be an appropriate claim to result from this research. Okay, so they're saying the new one is better than the old one, right? That's what they're trying to say. And we need to claim something. And so let's read through what they got here. So the new refrigerator model is more efficient than the old one. I mean, so far that's not too bad. That's kind of what we were asking for, right? It's almost a copy paste. Okay. The new refrigerator model uses 10% less electricity for the same cooling load. That sounds better because it has like a number on there. Makes it feel cooler, right? Literally cooler. Okay. It's only day one. You're not laughing. The new refrigerator model uses about this much per hour. But notice that there's nothing to do here about the old one. You see that? It's not there. So I don't think that's a good comparison. And then the new refrigerator model costs less to operate. I mean, that's still true. I don't have like a key to any of this. And so let's go back up here and look at the claim thing. Is there a claim up there? Right here. Write a detailed claim that addresses your concern or question. And then identify this and that. I think that's like the very first thing we're going to do. Like the very first thing. So which might be an appropriate claim to result from this research? I don't know. I would have to have Newton answer it for me. I know, your teacher doesn't know the answer. It's okay. It's not on the final exam. But I don't know. I'm just going to put a big question mark, literally. I know. We'll do it here in a bit. I know you're thinking, wow, this guy's crazy, and I am. But what I want to do is go to the homework here in a few minutes, and I want to see this question on the homework. And if it's not there, I ain't worried. Okay, if it is there, then we'll get to learn what they're wanting me to do. Does that make sense to you? I don't know everything, and it's okay because it's statistics. I know 98% of it. Anyways, so a researcher is interested in the effects of watching videos just before bed. Okay, he decides that watching, okay, there's the claim right here. Watching 1 hour of videos just before bed reduces the amount of REM sleep by more than 10%. Just seeing this right here, did you see it? This is the word claim, and then it has this nice, cool, long sentence here with numbers. It makes me feel like I can go back up here and probably do this one, which I was thinking earlier anyways. Okay, just my thoughts on that. Still a question mark. Okay, so that's what their claim was. How should the number of hours of video be treated? Okay, so let's go through the things that they have here. The number of hours of the video should be measured for each person in a sample because the variation of amount affect, okay, I can understand that. Number of hours for video should be controlled. Some measurements should be 1 hour and some should be with no video at all. What do you think? That one's pretty cool, right? Then you can see some that do, some that don't. The number of hours should be controlled. All people in a sample should be watching 1 hour. I think that this one's inferior to this one, right? Because at least we got the placebo effect a little bit, right? So I think that this, in light of these two, this one's better than that one. Okay, the number of, there it is. They said the word compare. So already B's looking pretty good. C is not, and I'm kind of questioning A. The number of hours of video should be controlled. All people in the sample should be watching no videos. That's definitely wrong, right? So definitely not these two. I'm looking at the top two, and the only one that I guess has more math and stuff to it, I guess, is probably this guy. Up here, it says it should be measured, but here it says it should be controlled. So think about it here. If you're just measuring how many hours that you're doing it. Some people can get all kind of different wild answers. Some people can be sleeping a lot more or not. Man, I'm watching like 5 hours of videos right before bed, and then I'm still waking up, and I don't really sleep. Or I could be watching 5 hours of video, and then I fall asleep while doing it. But if we control it, say, okay, 1 hour, 0 hours. Make sense? I like that better. Okay, keep going. So these are actually some of the more important ones also, definition-wise. And so, like, this is a hard break, by the way. Data collection. So we're trying to get different ways of collecting this data. And you can see that right here it was like 1 hour, not 1 hour, that kind of thing. How many hours did you sleep? Hook up the sensors, etc. So observational studies, you do not touch them. You do not do anything to them. You just let them do their own thing. So you're only watching. You're only watching them. Okay? You're not changing the environment at all. And what I often think of is like with ants. Yeah, I know ants are not that cool, but let's just say we're observing ants from the rainforest. Okay, so I go grab a big old pile of ants. They're gonna be huggy lovey, you know what I mean? And I dump them in a big old container, and I want to watch them. So me picking them up out of their environment is already changing stuff, right? If I wanted to be observing the ants in the Amazons, I should probably just go travel down there and watch them, right? What do you think? So that would be only watching, and I watch at them, and they're not going to touch me. I'm just going to back up. Okay, so only watching. Experiment. So now I have a control group and maybe a placebo, and so a treatment is applied. Yeah, I don't know how. Oh, this is examples. Oh, so this would be the ants. I'm just going to say watching ants. Can I do that right there? Watching the ants in the rainforest. Yep. Okay, awesome. So an experiment. And this is the example, right? I'm supposed to be experimenting on these ants now, and that doesn't mean taking some and no, I'm like, here's an idea. I know that sounds pretty bad, right? But they're ants. So I'm gonna take a sugar cube, and I'm just gonna go bloop and toss it in, and then you can see what happens with the sugar cube, right? Would the ants go and go and it's gone, or would they just like ignore it because it's like pure sugar? They don't really know what it is. And so I'm gonna say tossing a sugar cube. Toss a sugar cube in there. And now we're going to see what happens. I'm changing their environment. Do the ants in the Amazon in the rainforest, do they have sugar cubes? Nope. So I sure changed something in their lives, and now they're addicted. Simulation. So use a mathematical model to represent what's going on. I think that's pretty clear and defined there. But I could make. Oh no! You know what? You've heard of this video game way back in the day, maybe? It's called Sim Ant. There you go, Sim Ant. And I play the game, and I want to see what the ants do whenever I do this and that. I mean, it is what it is. Mathematical model, computer simulation, blah blah blah. Okay. They use this for like volcanoes and stuff too. So like a volcano erupts in Hawaii, what happens to the ash cloud, right? So they're not waiting for the eruption. They're wanting to kind of use math models and science and stuff. Survey. So you're asking them about all this stuff, and we've been talking about surveys already. So I'm going to ask the ants how they feel. Ask the ants how they feel about my presence. Yeah. So how do you feel about me being here today? What do you think about your sugar cube? Blah blah blah. And they of course respond by biting. It is what it is, guys. So y'all got the definitions down pretty much. You're understanding a little bit here. Let's go and answer some questions, okay? So, a study of the effect of the taste of a popular soda with less carbonation. I'm supposed to decide which data would be used to collect the data. So how am I going to collect this? A study on the effect of the taste of a popular soda with less carbonation. Should I experiment to see, compared with other sodas, less carbonation? Should I ask people about it? Do a survey? Yeah, because you're just asking, right? Should I simulate it? Should I make a computer program about like bubbles and stuff? No, that doesn't make no sense. So already I don't like this one. Should I just watch them? Should I go to Walmart and down the soda aisle and just kind of like, hey man, what are you picking? You're gonna pick that one soda? I don't think that this is gonna help either, personally. So you think a survey is probably the best? I think so too, honestly. Yeah. So like, hey, do you like Pepsi or Coke? You could. Hey, that's another. Let's choose it. I didn't say no to it. Maybe they let it go flat, bro. So, I mean, an experiment, what would that look like, an experiment? In Walmart, we have a table set up, and we have them this, we could even blindfold them if you want. And so that's still legitimate. I think both of them are. Does that make sense? I'm going to be okay with both. I don't know what, yeah, what's up? Ooh, that is a very good point there, because we're not putting like sensors in their mouth, are we? Yeah, I like that actually. Very good. Excellent. Okay, cool. So I'm gonna erase what I just, but I'm not gonna like cross through it. I'm gonna do halfway. I suppose so. That's a very good observation. Thank you. A study of how fast a cloud of volcanic ash would spread over a metropolitan area. Yeah, we were just talking about it. Yeah, the simulation's probably what's going on there. I know that we can probably wait for it to happen, but with the observational, but it would take too long, right? So a simulation of that would probably be better. A study of how often people wash their hands in the restroom. Oh, so you mean cameras? I mean, that's what you're saying. So, but you're right though. And so, to what level are we humans okay with that? Does that make sense? That's a tough question. So, in reality, what it might end up being is a survey. Hey, did you wash your hands? But you know how that's going to be bias. Exactly. And so, right here, what does observation mean? It means cameras, but we're not okay with that. So, do you know what I mean? It's a hard question, and that's part of statistics. That's part of this class. Is sometimes we just don't have a great answer. I'm actually going to leave that uncircled because both are legit, but in their own ways. Please do. Like, honestly, when it comes to exams, I'm going to look them over. And if you write down what you're thinking in English, I will read that because I read English. Yes, exactly. And you come complain to me and say, "Hey, my exam, blah blah blah." I'm gonna say, "Yes, exactly," and I add points because that's what I do. I swear to it right now. That's what I do in this class. Some of you already know that, especially here in statistics. Okay, a study of the success of graduates at a large university in finding a job within the first year. So an experiment here would like be taking a group of people and actually putting them through the school system and then seeing what they're doing. We have enough people already. We can probably just observe, maybe, or rather, that's me creeping up on them, though, right? That's me like, ooh, let me go find their phone number and where are they? We could just ask them. We can just ask them. We can just ask them. Oh. Oh. Wow. Okay. So that would take a lot of money and a lot of time, right? And that's maybe why experiment would not be the first choice here. Exactly. But still possible. Still possible. Very good. I like that. So yeah, I'm going to say survey is probably the easiest one for that one at this point. Okay. So a control, prevent for effects, other measures, blah, blah. Okay, whatever. Confounding variables can change things. There's really not much going on here. I don't know. Placebo effect. Have you heard about that? Do you know what that is? Okay, okay. Let me tell you. So, you are lined up, and you're supposed to be getting an experimental drug. Yeah, and so the doctor comes by and says, "All right, here's your pill for the day, and here's your pill for the day, and here's your and here's your pill for the day." He just laughed when he gave me mine. I don't know if that's a good thing, but like the point is that he's not wanting to know, and you're taking it could be sugar pill, placebo sugar pill, and then the point is that there's this blinding and double blinding that's also part of that. You don't know what you got, and also the doctor would not know. Does that make sense? And so that way he can't, and then all of a sudden you're freaking out, and you take it, and you're like, "Oh my gosh, I'm freaking out!" And then really, no, 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 that was just a sugar pill. That's okay. So that's why we have these other parts to this. Cool. Sugar pills. You don't know. They don't know. Very good. Very good. Cool. Randomization, you're randomizing it. Replication, you do it again and again and again. Cool. So observation versus experiment. We already had this up above. I don't even know if they're asking Oh, is this an experiment? Okay, so are we observing or are we changing? Okay, that's basically what it comes down to. Here we go. So a large manufacturing firm is interested in the effects of temperature, manufacturing, this and that over the year. They do samples of these sites and record the temperature. Da 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 da. Is that an experiment or is that just observing? Just observing, because they just went around and they didn't change anything. They just went around and measured. Bloop, bloop. And that was it. Done. That's how you measure temperatures now. You got the little sensors. You just click, click, click. We know here at CTC because the AC doesn't work. They come around and go bloop, bloop, bloop. Okay. A scientist is interested in finding out the effects of soil quality. Would he use an experiment or would he observe? Oh, and they got these options here. Okay, so this is an interesting question. So we got a soil quality something or other. Could you put fertilizer on the soil to make it better? That would be changing it, wouldn't it? Wouldn't that be an experiment all of a sudden? Versus observing, you're just watching two plots of dirt and seeing how much yield you get out of it. So here we go. An experimental study should be used with the crop quality as a controlling factor. And so the control is supposed to be the crop quality. I think it's the soil. It's the thing that you're controlling, right? What, can you control how many ears of corn grow on this versus that? Can you, human, do that? No. But we can put fertilizer on it. That's what we can control. Does that make sense? Okay, so I don't like that one. Observational study is used because the soil quality cannot be controlled. I just said we can do that, right, with fertilizer. I don't like that one. Experimental study because soil quality is the controlling factor. I like this one so far. Let's keep going. Observational because crop quality cannot be directly controlled. And I think that's false because we got fertilizer. Okay, makes sense? Okay, lots of blah blah, but you know, that's just one of those classes. And we got done with the first section. Woo! No, there's no clap. Oh, thank you, thank you. Oh, I know. We got to get out of here now, right? So we only got a few minutes left, and I don't want to start this up. So what I'm going to do is stop the recording, and we're actually going to go down to the advanced math lab, and we're going to do a little tour, and we're going to be done. So get your stuff. We're out of here. We're done. Thank you for hanging out, guys. Any questions? Any questions for the recording? Joke, they can't hear you. Goodbye now.